This is the second part of the lesson for Handout 2A. And so let's take a look at the first problem here. It says find the solution. The solution is also known as the point of intersection. It's where these two lines end up crossing for this system of linear equations. Linear just means straight lines. So if I were to graph these, they would form straight lines, and they'd eventually cross at a point, and that's what we're trying to find. And so what we're going to end up doing is we're going to use substitution on this first problem. So substitution is a great method when you have y or x equal to an expression. So what we can do is take this expression that y is, 6 minus x, and put it in place of this y. So we're going to rewrite this equation, 2x minus 3, but in place of writing y, we're going to write 6 minus x. And then this is all going to equal 22. So we go ahead and do some work here by multiplying negative 3 over that difference, and here's what we get. 2x minus 18 plus 3x equals 22. And so I'll go ahead and move some terms around, maybe combine the 2x and the 3x, and so when I do that I get 5x. And then minus 18 all equals 22. So I go ahead and move some terms around. I'll add this 18 to both sides. And when I do that, I still have this 5x now equals, and this makes a 40. And so when I do the division, you can see right away I'm getting a integer of 8. So x equals 8. Well, you're not done yet. You need to substitute. Put that 8 back in for this x right here and find out what y is. So y equals 6 minus 8. Well, we do the subtraction and we get negative 2. So there it is. X is 8 while y is negative 2. That's where the two lines cross. Let's take a look at our next problem. Now this one I would not use substitution for because, see, you don't have x or y by itself, but we do have the x and y's, equal signs, and constants lined up. So this is a problem in which I would end up using the elimination method. So I'm going to go ahead and multiply the top equation here by, let's go by a 5. And I'm going to multiply the bottom one by 3. I could have canceled out the x's by multiplying by negative 3 and positive 2. But I decided, since the signs were already opposite here, y's would cancel if I just came up with the common number. And so that's what I ended up doing, multiplying by basically the other's coefficient to be able to cancel out the y's. So here I've got 10x plus a 15y equals, and this makes 65. And so on this other side, I end up with a 9x minus 15y equals 30. So when I add these equations together, I end up with this 19x equals, and I add these numbers together, I get 95. And so now I'm ready to do some division. Divide by 19 on both sides. And let's see if it goes in there evenly. Well, 19 does go into 95 there 5 times. So think of it this way, 19 nickels makes 95 cents. So that's how I came up with that answer. So once I've got 5, now it's a substitution problem. I got to put 5 in place of one of these equations. Now I wouldn't pick these two because they're bigger numbers, so I'm going to pick one of these. So I'm going to put 5 right up here in place of this x. So now I've got 2 times by 5 plus 3y equals 13. So I go ahead and multiply this. I get 10 plus 3y. This all equals 13. So now I just have to subtract. Take away that 10 from all sides. You got 3y equals 3. Do the division, and that's how we end up with y equals 1. So there it is. X is 5, while y is 1. This is where the two lines end up crossing. Now, we use systems to solve problems like this one here. So John has a total of 25 coins. Some are dimes, others are quarters. The value of those coins is $3.55. How many of each type of coin does John have? Well, this is a problem in which we can set up a system of equations. And so I'm going to set up a quantity equation and a value equation. And so when I do this, my quantity equation is going to be the number of dimes plus the number of quarters equals the total number of coins, 25. And then I'm going to do the value equation. The value is the value of these coins. So we know that a dime is worth 10 cents. So it's 10 cents times the number of dimes. Quarter we know is 25 cents. So 25 cents times the number of quarters. Now we have to write the value. The value is $3.55, it says here. But I'm in cents, so I need to make sure I stay in cents. So that would be 355 cents. Notice there's no decimal here. So this equals 355 cents. Since I'm in cents, I need to stay in cents. So what they're asking for is the value, how many of each type of coin. So we can go ahead and multiply by -10, and this will cancel out the D's. And so now my quantity equation, I rewrite it, I get -10D minus 10Q equals -250. So when I add this together, I end up canceling out these D's. I get a 15Q equals, do the subtraction here, I get a 5, a 0, and a 1. And so when I go ahead and do the division, divide by 15 on both sides, it's going to end up being an odd number because when I'm dividing odd numbers, I end up getting an odd number, and 7 should be the number. So let's check. 7 times 5 makes 35. 7 and 1 makes 7, plus 3 makes 10, so that is right. So I go ahead and substitute 7 back into either of these equations, but the quantity equation is the easiest one. So all you have to do is do D plus 7 equals 25, and then just subtract that 7 from the total, and that would give us our value of D. So D equals, do the subtraction here, and that gives me 18. So there it is, 18 dimes and 7 quarters. So that's an example of where we use systems to solve problems in which we can set up linear equations for. Well, the next type of problem is a simplifying of this expression, and what you're looking for is common factors between the 33 and the 42. Well, one of the rules of divisibility is if the digits add to make a number that 3 goes into, you can divide by 3, and that's what I can do here. So I'm going to divide this number by 3, and I'm going to divide this number by 3. And so when I do that, it becomes an 11, and then I'll leave some room for x's. And then 42, well, 3 goes into 4 one time, and with 1 left over, 3 goes into 12 4 times, so it makes 14. And now we cancel out some x's. See how there's 4 x's here? We'll take away 4 from the bottom. That leaves us with x's left on the bottom of the fraction. So 11 over 14x to the third. Well, the next problem, we have to subtract some polynomials, and so when we do that, we'll add the opposite. So switch all these signs to their opposite, and then go ahead and put the numbers down below. -2x squared, a positive 8x, and a positive 9. And so I add this stuff together, and I end up subtracting these two because they're opposite in sign. I get 2x squared. Here I subtract as well because they're opposite in sign. I get a positive 6x. And here I add those two numbers, and I get positive 12. And that would be my answer. So remember, with subtraction, I would add the opposite and then just combine the terms. Here with addition, I don't need to do that because it's already addition. So I'm just going to take the terms that are similar and put them underneath the ones that I can combine them with. So I go ahead and write the 2x squared, -2x squared underneath the 3x squared, -4x underneath the -2x, positive 9 underneath the positive 8. And I add those numbers together, and just the same thing. If they're opposite in sign, I subtract. So I end up with an x squared. Same sign I add, so -6x. Same sign I add again, so 17. And there is our answer. One more problem here. Talks about the perimeter of a triangle is, and then this expression here, 2 sides total this. Find the third side. So looking at a picture of a triangle, all the sides, if I was to go all the way around, this perimeter is 3x squared minus 2x plus 1. Well, 2 of the sides, maybe these 2 sides right here, sum to make this value. And so what they want to know is, what is this third side? Well, if that's the case, what we can do is subtract. I'm going to subtract this expression from this expression. And so when I subtract, remember I add the opposite. So I'm going to add the opposite of these signs. And then from there, I'm going to put them underneath the ones I can combine them with. So the -x squared, the -9x, and the positive 4. And so I add this stuff together, And when I do that, I end up with a 2x squared, a negative 11x, and a positive 5. And that would be my answer. So that would be the third side. Well, those are some of the problems that you'll see on Handout 2A. Good luck.